All right, so now we're recording. Actually, it even, if for some reason you prefer to read things, it actually, well, you see, it gives you a transcript is what it's called of everything I say also. So if you didn't understand something I said, maybe if you look over there, it might have captured it. Sometimes it writes the wrong thing over here. Like you ever watch TV and you use closed captions, anybody like so you can read it? Like sometimes the closed captions are actually wrong. It's not what people said. It's kind of the same thing. It's not perfect, but just another tool that'll help you. All right, so again, wherever you're taking notes, whether it's on the worksheet, if you have your own notebook, like a composition notebook you want to take it on, we're going to do some background notes. So this is stuff that should be review. If it's brand new, I mean, it shouldn't be brand new. God dang it. World. Yeah, there. Now. Oh. All messed up. There we go. All right. So can anybody, so raise your hand if you're getting stuff out. I mean, always have notes out. Like, we're going to take notes every day. So. And if we don't take notes, you're going to use the notes that we just took. So no reason to not just go ahead and pull that stuff out. Back there, the first purple, 725 to 902. Raise your hand if you know what the distributive property is. Like you could actually do it. If I put a problem up there that used the distributive property, you already know you could do it without even seeing any problem. You're like, yeah, I remember what that is. And that's kind of what I expected. Like that's why we do this review stuff. Raise your hand if you remember hearing the term distributive property. All right, so more people remember. You'll recognize it as soon as I put it up there. I think you see it visually. The distributive property is extremely important for two reasons. One, it's used all the time, not just in my stuff, but I think in the FSA they use it a lot. But it's also probably one of the more difficult things in solving equations.
Yeah, isn't it?
Well, that's order of operations, and it is typically the first thing you do in order of operations. Why would it be the first thing you do in order of operations? So what is the first thing then? Parentheses. So the distributive property has to do with parentheses. So if you see parentheses in a math problem, it's not 100% of the time, but it's, especially in school, it's almost 100% of the time, you're going to be doing this distributive property I'm about to show you. So again, write distributive property if you don't know how to spell it. Oh, my board is all messed up. So that's distributive, D-I-S-T-R-I-B-U-T-I-V, distributive, and then property. Hopefully you can spell close enough to know what it means. So property. I guess I can write property. My board is just not. Yeah, I got to do it. My board is not writing where I'm putting my pen, so I'm going to avoid writing as much as I can probably. All right, figure that first. Yeah, all right, that all works all right. So distributive property, again, you're going to see it all over the place in problems, and it is probably one of the more difficult things for the first lesson that we do. The math of it is more difficult. I don't think it's super difficult to understand. You do not get a calculator. So there were rumors that the FSA was going away and all this kind of stuff. You still have an end of course exam. It didn't really change that much. I don't know why that rumor came out and they said, oh, it's going away, it's going away. It's not going away. I mean, you still have an EOC. Not this year, not in this class, but when you take the full year of algebra. We'll just have a midterm and a final in here, but the midterm is made up by the district. And actually the final might be the district, made up by the district also. So it will be a pretty challenging midterm and final would be my guess. My stuff I don't think is too bad. I'm not going to say it's easy, but I don't think it's too bad. The district stuff is pretty difficult. So the distributive property has to do with parentheses. So that's the first thing you look for. Now, the full distributive property has to do with something like this. So you have a number outside, well, actually it could be a variable theoretically outside the parentheses, very rarely is. But you have a number or a term outside of parentheses next to the parentheses, which is a key point. And then you have some kind of quantity inside the parentheses. It could be all numbers really, but normally there's going to be a variable. So now we're going to go over some big background things that kids struggle with throughout the whole year. I want you to write this note. So what is this? No, that is not multiplication. So that's the first thing we're going to write, not an exponent. So in math, in algebra, I should say, that dot right there means multiplication. We don't use an X for multiplication anymore. So that means multiplication. Everything else is the same. You'll see a plus sign, a subtraction sign. Well, actually, not everything else is the same. So write that. Again, you can write this on the back of the worksheet. If you're just doing it on a worksheet, you have a notebook, you can write it in your notebook. This is all background. This is like review stuff. If you don't want to write background knowledge, this is all review from pre-algebra and even before pre-algebra. But if you don't know this stuff, you're going to struggle a lot when we get into especially more difficult equations. So the other thing that you've got to change that you're used to from middle school. So what is that then if that's not multiplication? It's an X, it's a variable. It's a variable, which we'll talk more about variables in a little while. I might even do some like physical examples to show you what a variable is. I don't know if I'll get to that today. This is how you will now see division. It'll look like a fraction. We don't use the division sign that you're used to. I'm not going to say you'll never see this in this class. I don't ever use it. Occasionally it might be on a worksheet, or maybe if I'm trying to show you a problem in a certain way, maybe I'll use it, but almost never. This is how you'll see division. So that line right there in a fraction means divide. Remember your math, in order to change a fraction into a decimal, you take the top number and you divide it by the bottom number. That's because that line means divide. So that means division. I'll give you the example after I write that. I did not mean to write that. Oh boy, that was way off. So it would actually be 2 divided by 7. So there, that's what that means. That line. Yeah, I'll just leave it like that. You don't need to write. So you can kind of think of it as the line in the fraction, the middle line means divide. And it doesn't matter how much stuff is on top or how much stuff is on the bottom. It's everything on the top divided by everything on the bottom. So we could have a full equation up here and a full, or not really an equation, it'd be an expression, but same thing sort of. We could have a full like variables and numbers up here and variables and numbers up here. Doesn't matter. It is the top divided by the bottom. So you will not see, or well, you won't see an X anymore for multiplication. I'll never use that. I won't even, I mean, unless I miss it, I won't even have worksheets that has say X is representing multiplication, because X is going to be a variable all the time. So if I use it for both, how are you going to know when it's multiplication and when it's a variable? So you won't see that. Is it still going? Oh, it looks like it's still going. Normally it stops when that happens. I have connection problems sometimes in my room, so when we try to use online stuff, you may have connection issues. I'll just warn you ahead of time. I'll have printed copies, just kind of like I printed today. I won't necessarily have printed copies for everybody, because hopefully some people can. Laptops shouldn't have any problems. So if you have laptops, that's probably a better way to do it. All right, so the next thing we need to know. If those two things, if that means multiplication, that means division, what does this mean?
Is that a fraction?
Yeah, so a fraction means division, so this line means divide. For the next one, the 3y.
Don't talk about 2/7 fraction.
Well, that's what I'm saying. This means that. That's my point. Like, I'm just explaining to you what this means. So this thing right here means that you're dividing. You're taking the top divided by the bottom. I was just explaining. It's not two different problems. It's an explanation of that first problem. What does 3y mean? Yes, sir. Brave soul. Y is not a 1. I'm so glad you said that, man. Oh, and by the way, the culture in here needs to be one where we respect everybody. And the main thing I mean by that at this point is, if somebody says an answer that's not correct, don't make fun of them. Like, you saw that, how many hands went up when I just asked that question? 1. So if somebody's brave enough to answer a question, you weren't brave enough to try it, or you didn't know it in the first place. I don't want people to feel like they can't give an answer because they're scared, or if I'm wrong, somebody's gonna make fun of me. That cannot be the culture in this class. Math is not easy, especially once you get into algebra. Math gets a lot more difficult. Pre-algebra is not too bad, but we're in algebra 1 now. We're doing algebra. Now, this is not the algebra 1 class, but it's the same exact material they do. There's no difference. It's not watered down, meaning I don't make it easier. We just get a little more time to go through it. So you're going to get challenged. You're going to get frustrated. You cannot give up. Has anybody had a teacher talk about growth mindset yet?
Yeah.
Or in the past, even like, you have to have a mindset of I can always get better. You can't shut down. Can't get frustrated. You can't give up. And this is, again, I'm not just talking about math. I'm talking about life. You will never succeed if your mindset is, oh, it's too hard. There's nobody that's successful that just had everything go right every time they tried something new. Most people that are successful have failed way more than they've succeeded. There's a raise your hand, better all, well, maybe not all. Who knows who Michael Jordan is? Pretty famous. Arguably the greatest basketball player of every time. Also arguably one of the greatest leaders that ever lived. He's still alive. He's got a poster, and I wish I had the big version of it, but there's a little quote on here. Yeah, this one right here. If you ever want to read that, that's from Michael Jordan. I didn't write Jordan there, but that's from him. And it's, I'll read it because I love it. I'm a big sports fan, so I'll say lots of times. So I'll read it to you. It says, and it doesn't say who it's from, so you already know, but it says, I've missed more than 9,000 shots in my career. I've lost almost 300 games. 26 times I've been trusted to take the game-winning shot, and I've missed. I've failed over and over and over in my life, and that's why I succeed. So the concept is you can't be successful without being willing to try. And that's in anything you do. That happens to be sports, or business is the same way, school is the same way. So we'll talk about that a lot. So my point is, I'm kind of preaching right now, which I do not. If somebody gives an answer and they're willing, I don't care how crazy you think that their answer is, don't make fun of each other. We support each other because, like I said, odds are most people didn't know. So anyway, so the reason I was glad, though, that it's Charles, right? The reason I was glad he said 1 is because let's say it wasn't 3y, it was just y. We'll get back to that one in a second. Then people say, oh, well, now y is 1. No, y is still not 1. Now, we say that technically y is the same thing. So here's another note. We'll come back to 3y. Just having a y is the same thing as 1y. So you can say there's a 1 in front of it, but that does not mean y equals 1. Y is a variable. We'll get to the definition of a variable as the next thing after we talk about what 3y means. So there's two things I'm going to tell you that 3y means. You really just have to understand one of them. So if one of them makes sense to you, you can pretty much just use that one. If you understand both of them, that's fantastic. Solving equations won't be too bad at all for you. 3y means you're actually multiplying. And I'm going to use my dot for multiplication because I'm not going to ever use the x. So 3 times y. Anytime you do not have a multiplication symbol, or any symbol, I should say. So you don't see a plus sign, you don't see subtraction, there's no like fraction, so it's not division, then the math operation is multiplication. So if I have a 3 in front of a y, that means 3 times y. I could do that with variables also. I could have CD. Again, we'll get to what a variable is. So if you're freaking out, what a CD is 2 variables next to each other. I'll do XY if that's more familiar. That means, and I'll scroll back to the top. And today's going to be a pretty boring day because I'm just going to give you a lot of background notes. We'll get into doing some problems. The first day of a lesson is a lot of times the most, okay, but it's also the most important because you need to have all the notes so that you can then kind of be on your own for the rest of the practice. So anytime you see a number next to a variable next to a variable, it means you're multiplying those two things together, right? It doesn't mean if I tell you x equals 4 and y equals 7. And again, this may seem basic to a lot of you, but I'm just making sure we're good. It doesn't mean if x is 4 and y is 7, that that's the number 47. Doesn't mean that. It means you take 4 and you multiply it times 7. So if you struggle with math, say what I would do. Every time I see something like this in a problem, I would rewrite it. And I would say, this really means C times D. I'd rewrite the whole problem and put the multiplication symbol in there, and then I'd work the problem out, do what I need to do. So I remember always that that's multiplication. And the more times you do it, eventually you probably won't have to do it anymore. Any questions? I know I'm bad, but this is all hopefully reviewed. And it'll be recorded, so you can always go back and review. If you're struggling with background knowledge, like you don't remember a lot of stuff from middle school, you may need to go back. I've got other videos that are like background knowledge videos. You may want to go watch some of those on my website. Like, for example, one is just adding positive and negative numbers. Because there's a section of the EOC, the algebra test you take next year, where you don't get a calculator. You have to know how to add positive and negative numbers on your own. There's no calculator on that section. It's like a 45-minute section or something. All right, so back to 3y real quick. It means 3 times y, but it really also means this. I'm going to write this in a different color. It really also means that. You just have 3 y's. So that's the other way. I said, if you remember one of the 2 ways, then you should be good. You could literally write out, every time you see something like this, you could write out, oh, well, that just means that I've got 3 y's. So it's not a number. Y is, I mean, it is a number, but I'll get into the variable next. You can't say y equals 1. Like this is not 1 plus 1 plus 1. It's y plus y plus 1. Or 3 times y. Because remember, a multiplication is just a shortcut to addition. If you're adding the same number over and over and over again, well, we'll do it real quick. Real quick. Who's super good at mental math? If I want to take the number 3, we'll find out. If I want to take the number 3, and you can write it down on your papers and do it if you want to write it on your paper, or you can do it another way. Like you can try to do it in your head. I want you to add the number 3 8 times. Go, who's fastest? 3 plus 3 plus 3 plus 3 plus 3 plus 3, 8 times. 24, super fast at adding, right? He's the fastest addition guy I've got in the room, right? Where are you? Did you add them all together?
I'd say 23.
Yeah, multiplication is a shortcut to addition. You don't add 3. Oh. So Sway, if you want to step outside real quick. Okay. All right. If you want, you can go on to So when we're adding the same number over and over and over again, it's just multiply. How many of the numbers you have? So I said do it 8 times. And the number we were adding over and over and over again was 3. So Malachi said, well, that's just 8 times 3. I don't need to add 3 over and over again. So when I'm adding y over and over and over again, I don't really need to write it as y plus y plus y. I just say, well, that's the same thing as 3 times y. Because y is a number. Here's what a variable is. So write this down. Actually, I'll write it for you. I'll do this one in red. I'm going to write the short version. We'll talk more about it next week when probably have some other people in class. Do you know what this, like the symbol for number is? Like the shortcut version of it? You might know what the shortcut version of the word number is. The hashtag, yeah, that's what you guys hashtag. So unknown, I'm going to do a lot of shortcuts, so I'm going to start introducing it now. A variable is just an unknown number. If you want to write the word number in and you don't want to use that, I guess I'll write it below it real quick, just in case. But that's the shortcut I use. So I would encourage you to have your own shortcuts for your notes. You don't have to sit down or sit there and write every single word that I write. Sometimes you can just leave words out. You can change words to shortcuts. It'll help you in all of your classes, not just this class. But a variable is just an unknown number. We don't know what it is. It's kind of like saying this. Kind of like saying, I'll give you a word call example. Calling somebody. I'm going to call her Maya. Maya's super smart. Great. So, Maya, you can go to the movie with some friends, all right? Go to the movies. You are going to buy the tickets for all your friends. All right. So you spend $50. How much were the tickets? So you bought the tickets for all of your friends. How much were the tickets? Why can't you tell me? Don't know what? Am I giving you enough information to figure it out? I have not. I haven't given anywhere near enough information, really. What do we not know? You know you spent a total of 50, but what do you not know? You don't know how many people. How can you figure it out if you don't know how many people? How can you figure out, well, how much was each ticket if you don't know how many people went? If only one person went, if you just went, it was $50 ticket. If 10 people went, they were only $5. So that's why we use a variable. We say something like X times Y would have to equal 50, and 50 is the dollar. What are X and Y going to stand for?
Cost.
Yeah, the cost of it, and I didn't really tell you which variable to use for which, so you could say whichever one you wanted. But one of those is going to be the cost of one ticket, and one of those is the number of people. So that's why, and we almost could use it's almost like using a question mark because we don't know it, but we can't use a question mark because I need to know one of them stands for the number of people and one of them stands for tickets. So we got to use different things. We can't use just 2 question marks because 2 question marks, we don't know which question mark stands for which thing. So you got to somehow make them different. And that's why we use the letters for variable. Have you ever seen on Facebook, like, I'm a fantastic artist, by the way, if you didn't know. Most people don't know that. So about me, I'm a fantastic artist. That times that equals 10. Have you ever seen something like that on TikTok or Facebook or whatever social media stuff you do? It's saying, what is that? I'm a horrible artist. It's an apple. It is an apple. Good. Sometimes people don't. So that's saying an apple times a banana is 10.
Like how many apples I know.
Well, it's not saying how many, it's saying one apple times one banana is 10. And there's a value associated with that. It's just a variable. Instead of using a letter, we're using a picture to represent it. So technically, if this is confusing, you don't worry about it. A variable is really just anything that represents the unknown number. So sometimes you may see worksheets that have pictures that represent an unknown number. Like they may, I can't even think of a time when we saw it, but my point is a variable is just an unknown number and we have to represent it with something. We choose letters in math. We could have chosen pictures. We could have chosen maybe something else. I don't know, a set like symbols, like instead of using letters, we could have used Greek letters or something like that. But so a variable is an unknown number. Right? We don't know what it is. It's a number. And if it's in an equation in multiple places, it's always the same number. You can never have x be 3 in this spot over here, but over here it's 5. So you may want to write that down. A variable in an equation is always the same value if it's in that one equation. Harris?
You said always the same.
Always. So I'll give you an example. If I have this right here, x plus 4 equals 7, subtract. Actually, let's change that. If I have that equation, again, that's not multiplication in there. This x doesn't mean multiply. It's a variable. It is an unknown number. I don't know what x is. Now I could solve it. You can actually solve it. I want you guys to solve that. Figure out what x equals. If you can come up here and grab a worksheet, you'll see the top drawer up there has pencils, if that's what you're asking. Did you already grab the worksheet? I think so, yeah. Yeah, so if you need a pencil, the top drawer. Once I run out of pencils, I told if they don't have notebooks, I said I would just take the notes on the back of the worksheet for now. And then on the front, when we start doing the problem, you can just put the notes there, and then I will put it in that and keep it in the room. So second period has a box over there. Who's got it? Yeah. I don't think it's 2 because how would I know if it's 2 or not? How would I know if that's right? If I plug in 2, I should get the same thing on both sides, right? 2, oh, that's not 2 plus 6. 2 plus 4 should equal 6. Subtract 2, is that correct? 2 plus 4 equals 6, subtract 2. What do you get on the left? What's 2 plus 4? 6, right? What's 6 subtract 2? What is 6 subtract 2? Not 6, right? So that wasn't right. Because it has, the left side, we'll get into what an equation is, but the left side has to equal the right side. Well, that didn't work. So that wasn't the right answer. So let's try 10. So I'm going to erase that. Again, in order to solve for x, you have to make the left side equal the right side. That's what solving basically means. Get the value of x that will make the left side equal the right side. So if I plug in 10, I think somebody just said it. Is that going to be the same on the left and the right? Somebody just said the answer. 4 plus 4 is 8. 6 subtract 4 is 2. So that doesn't work. Let's try 1. 1 plus 4, 5, 6 subtract 1 is 5. So x is 1. It's got to be the same number. Can't be 2 different numbers in the equation. So no matter how many times x appears in that equation, or whatever the variable is, it's always the same value. It's an unknown number. Like we didn't know what it was initially, but and now you won't always be able to solve for it. Sometimes you won't be able to solve for x. If you only have one variable in one equation, though, you can solve for it. All right, so that was not part of what I was going to do, but that's all right. Yes, ma'am.
Can I come to
Yeah, you can do that like at another time. You need to be in here for the lesson. I mean, unless there's something you need to do right now, like if they need to give you something right now.
I know, I just wanted to do it right
No, I don't let, and we're not actually supposed to let you do just errand stuff during class. Like, you need to be in class doing the lesson stuff. Now, if we're completely done, there's nothing going on, then I might let people do errands, but like, you can't miss a lesson to drop something off to another teacher or a clinic. All right, so let's go back. So we started this with a distributive property. Tell you what. Oh boy. Great. Okay, so again, this is where we have to build a culture of, I'm going to put forth some kind of effort in this class. Mr. Gill asks a question. I'm not just going to be lazy and sit here in my chair and not raise my hand. I'm going to give him an answer. Trust you to do that. But ultimately, it's you that has to pass the test. So if I don't understand where everybody's at, because nobody's giving me an honest answer, then we're probably all going to fail. You, everybody. So here's my question to you. Looking at that worksheet, look over the first page. You can look at the second page, but really you only have to look at the first page. Look at those problems. Some of them have fractions, which are definitely going to be more difficult ones. I'm going to ask a question, and I want you to raise your hand, and gradually I'll keep asking it until hand starts to lower, and we'll see how many. All right, so now we'll let Malachi look here. Although Malachi probably knows every single one. All right, so looking at those problems, there's how many on the first page? I'm just talking about the first page, so 18. Raise your hand if you feel pretty comfortable. You can do all 18 of those. Right, so somebody thinks maybe. Raise your hand. Actually, let's do it the other way around. Raise your hand if you feel like you can do one of those. If there's one on there you're like, I could solve that. And for now, we'll just say I don't even care how you solve it. If it's just plugging in numbers and trying to figure out which number does that variable have to be, you could do that. So raise your hand if you think you can do one of them, at least one of those. You can do more, great. Boy, I've only got a couple people that think they can do one problem. And if that's the case, that's fine, but don't sit there and be lazy. If you think, okay, well, I can figure that one out, I need you to raise your hand. So again, raise your hand. Let me see them. Few more hands went up. Raise your hand if you think, again, there are a lot of fraction ones. Raise your hand if you think you can do. Raise your hand if you think you can do at least 3 of them. A few hands went away. Still a few up though. Raise your hand if you think you can do 5 or more of them. Lots of a lot more people. All right, so we're gonna go slower. That's the purpose of that. If I had everybody's hands going up, we'd speed up a little bit. If people are, again, that's why you got to be honest, because I don't want to sit up here and be telling people stuff that you're like, oh my God, this is boring. I don't know why he's doing this. That's why I'm trusting you guys to tell me where you're at. So I was just going to have you start on the worksheet, but we'll do a couple of them together. First, though, we're coming back to this distributive property. So just like we said, a number next to a variable, like when you did the 3y means 3 times y. When you did the x next to the, actually, yeah, was it? I think I did x next to y also, or c next to d. That meant x times y. You'll notice there's nothing in between this 3 and those parentheses. That also means you're multiplying. That's what the distributive property is. It means you're taking, and I'm not going to go into why today. I think I have a video on my YouTube that goes into why it means that. Today, I'm just going to tell you that's what it means. This really means 3 times, again, you better learn that dot means multiply, because you can see it all over the place. You're going to see no symbol at all, like no math symbol, and you need to know that's multiplication. And you're actually going to see that more than anything, no symbol at all for multiplication, but you're also going to see that dot a lot. So you've got to remember that means multiplication. But that really means the number 3 times x plus 1. Because there's no math symbol in between them, just like there was no math symbol in between the 3 and the y, or the x and the y, or the c and the d. Got to know or remember, and again, it should be in your notes. So for the practice, you shouldn't have to really remember it. That's going to be my next question. Now what do we do?
So.
So let's talk about this. What can we do with these two things, the x and the 1? X plus 1. What can we do with x plus 1? What is it? What does x equal? Doesn't equal 1. Remember, we just went over that. So the first thing you need to know is x does not equal 1. X is an unknown number. I don't know what x is. It's a number, but I don't know what it was. If I knew what it was, I wouldn't have the x there. So if you see a variable you don't know, so you need to write this note down in your own words. If there's a variable in the equation, we don't know what it is. We wouldn't need the variable. If we knew what the number was, we wouldn't write the variable there. So if you see a variable, now later in the problem, they might tell you what the variable is. So like at the end of the problem, they may say, well, let x equal 3, or if x equals 3. And then you can plug that number in instead of the x. But if you see a variable, you don't know what the number is, else you wouldn't need the variable. You see a number. So a variable means you have an unknown number. You don't know. Now you might be able to solve it, or they might tell you what it is. Unknown. So if this is an unknown number, how do we, or can we add x and 1 and come up with something? Take x plus 1. Come up with a number. How do we know it's 4? I'm not talking about the 3. I'm just talking about, because remember, what's the order of operations? Oh, let's write that down too real quick. If you don't remember this, write this down. If you really have it down, then you don't have to write it down. So the first one stands for parentheses. You can either spell parentheses out, or you can just write the symbol. So these are parentheses. You can just write parentheses there. So the next one is exponents. This is the order that you solve a math problem in, always, no exceptions. So next you look for exponents. Now here's the tricky part. I'm going to change the way this is. We really should write it like this. Yes, we really should write it like that. Because multiplication doesn't always come before division. Like we don't skip over division to do multiplication. We just do those based on whichever one comes first in the problem. We'll get more to that when we start solving out. So that's multiplication or division. And then this one, addition or subtraction. But again, we don't skip division to do the multiplication. If we're doing a problem from left to right and there's division that comes first, then we do the division. Or if once we get to the last step, if there's some subtraction that comes before addition, then we do the subtraction first. Don't worry too much about that. Just write that down for now.
Oh, so it'll be 1 times.
Well, hold that thought for just a second, Dustin. Okay, let everybody write that down. I might ask another question. So the first thing we're going to do in this problem is what's inside. So when it says parentheses, that means you're trying to do what's inside the parentheses. So maybe if you want to write inside parentheses, you're trying to do what's inside the parentheses. There is a problem though. If I don't know what x is, and I don't, that's what a variable is. I don't know what it is. How can I possibly add some number I don't know to the number 1 and get one answer? Like I can't. Maybe x is 1, maybe it's 10, maybe it's 100, maybe it's -4. So here's your next note. and I'm just gonna say this one, so listen and write it down. Everybody tune back in, because this is one of the biggest mistakes kids make for the first quarter, whole first quarter. Actually, some of them all the way through the year. You can never, and in big capital letters, right, never, ever, never, ever, add or subtract a term with a variable. So that just means like something that has a letter in it. 3x, 3y, 10x, 10y. I'm not a big fan of drinking in class, so because ultimately it spills even if you have caps on it. So we don't do food, we don't do drink. I open it up to that at some point. If you want to step out in the hall, I don't mind that. But every single year, without fail, even though that's the rule, something has spilled on somebody else's stuff. Every single year. So trust me, there's a reason for everything I've got. Something has happened in one of my classes, and that's why I became a. So again, as long as it's outside, away from people's stuff, you know, that's pain in the butt. But I have to be fair to everybody. I can't let some people do it. And try not to get up and walk like right in front of the lesson. When you're going to step outside, try to hang on until we're at a break or something. So I cannot add x plus 1. If it would have been 6y subtract 7, I can't combine those. It's not, it doesn't become, this doesn't become 2x or just the number 2 or 1x or any of that. I don't know what x is. Like, how can I combine them when I don't know what x is? So there's absolutely nothing I can do with what's in those parentheses. That's why we need the distributor property. If you're not understanding all of the whys about this, it's not going to kill you. It's certainly better if you do. If you don't understand, I mean, hopefully you understand what a variable is now, but if you don't understand what I'm saying about why you can't combine stuff or why you can't do this or that, you can probably be okay with knowing how to do stuff, the process. The more you understand it, though, the better and the easier you're going to find the class. So the better you're going to do, the easier you'll find it. So what I do, I'm going to come all the way down. So I'm just continuing this at the end. If you have room where you had distributor property or on the side or something. So when we have the distributor property, and we'll just start solving some problems after we do this one. If I have that 3, so I've expanded it out. So the 3 times x plus 1, I can't do anything with the x and the 1. The only thing I can do, and you probably will recognize this, hopefully. We draw in these 2 little lines. And those lines mean I'm going to take this 3, and since I can't combine these into one thing, and then I would have multiplied that one thing times 3, I'm just going to multiply 3 times both of those. Because I can't combine them into one thing, but I can still multiply this 3 times both of them. So I write 3 times x and 3 times 1. If you want, you could make this 1 in front of the x, if that helps you understand how to multiply the 3 times the x. Because remember, there is a 1, technically, it's called a coefficient. Remember that word? But that doesn't mean x equals 1. How many x's do you see in that problem? In this original problem up here. There's 1, right? There's 1x. That's why you put a 1 in front of the x, because there's only 1x there. If there are 3 x's, you'd see a 3 in front of the x. If there's 10 x's, you'd see a 10 in front of the x. So the number, and I would write this one down too. The number, boy, I've failed you forever about that. The number in front of the variable, it doesn't matter what the variable is, y, x, z, m. The number in front is just telling you how many of those variables you have. So if there's only one of them, then technically you could say there's a 1 in front of it. If you had y plus y plus y plus y, how many y's do you see there? Well, it's 4y. That's all the coefficient does, the number in front. Just tells you how many of them there are. Technically, it tells you how many of them you're adding together, but you could just think of it as how many are there. So it's not like a weird, crazy mystery thing. It's just how many variables. You ask me a question. Tell you what, go ahead and go out. I've held you forever. I apologize. Like I said, the first day of the lesson, especially if we're starting a brand new lesson, is a rough day. And then Maddie was that question? Well, what did I say? You never do what?
Subtract a small.
You can never add or subtract a term, which just means it's got a variable in it, with a number, like no variable. So I can't say x plus 1 is 2x, or just 2, or 1x, or just 1. Like I can't combine them into one thing. So I'll give you another example just real quick. I can't say 4t subtract 2 equals, I can't do anything with that. I can't come up with just one term. I don't know what this is. If I don't know what that is, how can I possibly come up with some end? I can't say that it's 2t. This wouldn't be correct because again, I don't know what that is. If it's a million, then that would make this 2 million, like if t was a million. But wait a minute, if it's only 1, then that would make it just the number 2. So I get different, like there's no way to combine them. So if you see a term with a variable and you're adding or subtracting just a number, you can't do anything with it. The answer is the same thing. 4t subtract 2, the only thing I can say is that's just 4t subtract 2. That's it. Can't do anything else with it. That is one of the biggest mistakes kids will make throughout the entire quarter, if not even the entire year, is they're still at the end trying to make that one thing. Can't do it. Not when you're adding or subtracting. My board really is the worst smart board ever. It's so slow. All right, so back to the distributive property. So what I would do is I'd multiply it. So this is the exact process you'll go through, by the way. I don't care how complex the numbers are, if they're fractions, negative numbers. I would write it out as like maybe a separate part of my paper, not in the problem, so that'll get confusing. So I'm just going to take this number times the first thing. So I wrote that there. What does that equal? What's 3 times x? What was that? Yeah, it's just 3x. We really didn't do any math. All we did is we took away the multiplication symbol. And we just said, well, I'm just going to rewrite it as 3x. It still means 3 times x. I didn't change anything. I didn't really do any math. I just wrote it and made it look a little bit cleaner. So 3 times x is just the same thing as 3x. I could theoretically write it as x plus x plus x if I really wanted to. That'd be fine too. I'm more than fine with that. What's 3 times 1? So you write 3. Now you write those together in one. And these are both positive because everything was positive. So they were both positive. Everything was positive. X was positive. 3 was positive. There were no negative symbols anywhere. So now I just take the 2 answers that I got for the individual multiplication problems and I rewrite them into 1. 3x plus 3. So 3 and then times in parentheses x plus 1 would simplify into 3x plus 3. Now I'm not going to, well, again, I'm really not grading any, like giving you a grade for any classwork. So if you skip over these steps and you don't show all of that, if you don't show the lines, if you don't do any of it, but you get to the 3x plus 3 part, as long as you can get to that final answer. I'm breaking it down into baby steps in case we don't necessarily remember exactly how to do some of this stuff. So let's see. I hope there's one. Oh, don't tell me they don't have any distributor property on the one I copied. They sure don't. All right, so I'll get you one for the next class. Well, oh, by the way, when I give a worksheet, normally, especially if it's the first day of the week, we'll use it for the whole week. Now we start out on Wednesday, so we'll wind up probably using this through next Tuesday. I might even I will add another one that has distributed property problems. I thought this one did. I can't see, I'm blind. I don't want to be. Tell you what, let me give you a couple of these to do since it's not on that. Well, and we'll do them together as a class. I'm going to give you one that's easy and then maybe one that is a little harder. Hold on just a second, bud. There's one you can try. I'm assuming that's not okay. Oh, I forgot to do the bathroom. So remember, he was supposed to get the bathroom pass and I was supposed to take his phone. Totally forgot because I had told him to. I need to make, oh, here it is. I need to make one up that's like more durable. All right, so you guys try to do that. Again, you won't come up with just one number. You can't. You can't combine this and this. So you're going to have two parts to it. Something, I'll just tell you, it's going to be something plus something. That's how I know I'm talking too much because I'm coughing. I'll start walking around in a second as soon as I try to fix this pass. All right, that's fine. Who was it? Maddie, or you wanted to go after? Are you done? Good. Okay. Yeah, I typically don't let you go anywhere unless you've done what I've asked you to do. So good. Done. You're supposed to be doing the distribute. I know you're out. You missed this part of it, but supposed to be doing the distributive property. I'll show you a quick example. Oh, I can zoom out a little bit. Maybe I can. Here we go. There. So that's the distributive property. So I went from this. That means take this times that, and then this times that, and that gave me the final answer of 3x plus 3. I want you to do that with the one down at the bottom. Done? Let me get my glasses. And again, a lot of you are going to want to slack off and not do this, especially since you're no longer getting grades for it. Can't practice this. Can't come up with one answer. We just said we could never, ever combine this. This has a variable in it. That doesn't. Remember, you can never combine something with a variable and something that doesn't have a variable. So you won't get just one number. No, look at what I did on the board again and see if you can figure. So look at the 3 times the x plus 1. No, wouldn't be that. You got part of it right because you missed one step. Working. Oh, yeah, boy, funny when I walk right. So we got the drawing into working. Looks like we're struggling. Which is fine. That's why we start early. Some people don't cover material the first week. We don't cover it. We'll be so far behind. But again, hey, I don't care if you get it wrong. I can fix getting it wrong. Can't fix a blind thing. I don't know whether or not you get it and what you're struggling with. I can't fix that. I can fix you getting it wrong. It's not an issue. The exact same thing, just different. I didn't even change any symbols. I didn't even put any subtraction or anything. Right now you can't combine it. You can never combine something with a variable and number. But what did you do here to get a x? So what did you do here that we get 7? So you did what? Did we say 3 plus 1? So it should have been 3x plus 3. That's what this was. So did I add 3 and 1 to get that in 3 or something? So it's always 1. Now again, you can't add any flow. You can't divide it, remember what this means. You can't, I've got a term with an x, and I've got a term with no variable. I can't combine it. This is right. Actually, that's not. You have this ready for, oh no, you wrote it right before. You wrote it this square. Careful. Some of you are doing the right stuff, but then you're making almost silly mistakes. Perfect. That's my goal. That's why I want to keep you in the grade. Good. All right, so we got a few that got it right. We got a lot that are still a little confused, which is why we practice. Again, I don't expect you to be perfect the first time we do it. I don't ever really expect it perfect.
Like the final. You're getting some of the right stuff, but then you're writing the final wrong. So watch what I do again. So I'm going to walk through that same problem. What? Hopefully you guys can see that okay. Oh, wait, hold on. I can fix that. Yeah, hold on. Hold that thought. This is where I do like technology. There we go. So look at, let me get rid of that. So look at the 3 times, so I'll go ahead and write this to the side. So this is the same thing as 4 times 2x plus 3. So there's no negatives. So it's the same exact steps. You're not going to have to make any adjustmts for a subtraction sign or a negative sign in front of the 4 or anything. What did I do in the problem with the 3 times the x plus 3? What did I do? I couldn't add. So here's where some of you made a mistake at the end, not in the beginning. You eventually got down to an answer where you had something with an x in it and just a number, and then you tried to combine those. It's the same thing at the end of the problem. At the end of the problem, if you got something with a variable and something without a variable, you can't combine them. You just leave them like that. So we'll have, just like this was my final answer. I didn't combine those. I didn't say that's 6x or 6 or any of that. I left it like that. That was it. So if you're trying to combine those and get one thing, you've got to get away from that. I would say half the people that got to the final answer tried to do that. Some of them had the right final answer already, but then they tried to do another step. There's not one. That's it. I cannot do anything with that. So what was the first thing I did? Well, this was technically the first thing I did, but I already did that for you. Now what did I do? And you can literally tell me the little tiny baby step I did. What did I do before that? Some of you won't even think of this as a step, but I consider it a step. I drew something in. Well, I drew the dot in already, but after I drew the dot in up there, what did I draw in? The lines. The lines will help you. Like it's a memory thing. When you do that, you should associate, okay, this line means I need to multiply these things together. So in drawing the line, like write a note. This is where I say you got to become accountable for your own notes. Write a note in your notebook. So now draw the lines. So say, oh, I don't want to use red. So write the problem. Again, I would put the multiplication symbol in there. So I would draw the lines, but after I drew the lines, like to the side, especially in your very first example problem, right? These lines mean to multiply those things together or something like that, whatever you want to write. And once you've done that 2 or 3 times in practicing, you won't need to anymore. You may still want to do the lines, but you'll remember, yeah, these lines mean to multiply. So these lines are telling me I need to multiply 4 times 2x and then 4 times the 3. A lot of you added the 4 and the 3. We're multiplying. So write in that those lines both mean multiply. So I would write 4 times 2x, and I'll solve that in a second. And then I got to multiply the 4 times the other thing, 4 times 3. Oh, and the thing about this new assessment process too, there's 5 stages. So this is a 0. That means you've done absolutely nothing. You've either not turned anything at all in, or I mean, this would be pretty hard to do. I've had kids be in this situation. You got absolutely nothing right, like nothing. Like, see, there's nothing that you did on that paper that was correct. Just doing that. If you just draw the lines in, that gets you off of that. you still haven't really done any math. I would say, okay, they at least understood that this 4 needed to be, the word is distributed, needed to be distributed to both numbers. Even if you add instead of multiply from there, if you do the math wrong, that would take you off of a 0. And the next stage is a 40%. So literally for drawing those lines, if you, let's say I had 10 problems and all you did was draw lines in, went to a 40%. Zeros will kill you in this class. 40% won't kill you. Because you're going to do some things, like you're going to get some stuff and get that correct, and hopefully get some hundreds, and remember you can retake stuff. So you got to practice, and even if you only get a couple of steps down, you're like, I keep getting stuck after that. That might be enough to do okay. Just can't give up. Can't give up and just do nothing. All right, so now we've done that next step. So you guys should hopefully have all this up there. You're not just sitting here watching and not doing it. What do I now do? What I say to do next? Yeah, you multiply them out. You say, well, what is 4 times 2x? 8x. So I say equals 8x. So there's my first answer that I'll wind up putting in my final answer. What's 4 times 3? Again, a lot of you added those two together. Probably at least 4 or 5 people added the 4 and the 3. They multiplied the 4 and the 2x, but then they added the 4 and the 3. Multiply these lines, both lines, the little line and the big line, mean you're it's because of this symbol here. This multiplication is being used with both of those. So now I just rewrite it. Again, everything's positive, so I don't even have to worry about anywhere if I have a subtraction sign anywhere. Now what do? 8x plus 12 is what? Exactly. It's nothing else. 8x plus 12 is 8x plus 12. I cannot. So this is what your note that I had you write earlier means. I cannot combine ever. And by combine, I mean add or subtract. So I told you to write add or subtract, so I should stop saying combine. I can never add or subtract a term with a variable. This is a term that has a variable in it. It's got an x with it. And something that doesn't have a variable. And if they're different variables, I can't combine them either. So if this would have been 12y, I can't combine that either. It's got to be the same variable. That's what a like term is. So that is your final answer. That's it. All right, so we're going to do one more pretty easy one. I'm not even going to get into negatives today since we had a little trouble on that one. So let's do 3. I've already used 3. Let's do, actually, we'll switch back to regular. 2. And then we'll say, I'm going to make the math a little tougher. So the math got a little tougher, but the steps are the exact same. Numbers are just a little higher. All those are 2 makes it. So I want you to do every step, like show me everything worked out, or show me everything written out, and then work out the math, and then give me the final answer. Remember, the final answer will have a variable term and a number. I'll try to combine those. And that will be the last one. Perfect. Did you get the other one right? Did I not check you? I don't remember. Awesome. I'll be right here. Oh, you combine. Sure, but we can never, like that's the, for today's lesson, that's the biggest thing to remember. I can